Problem 35. A dairy farmer uses a storage silo that is in the shape of a right circular cylinder above. If the volume of the silo is 72 pi cubic yards, what is the diameter of the base of the cylinder in yards? Now, there are some geometry questions that are on the SATs that appear to use formulas. Here, the volume of a right circular cylinder. Well, in the beginning of each section of math on the SATs, there's a table of formulas that are given to you. And here's a copy of the formulas that are given to you on the SATs. And it's important not that you have the formulas memorized, because obviously you don't, they're given to you, but it's important that you know which formulas are there. So anytime you need the volume of a shape, here they give you 5 different volume formulas. So here we're using the right circular cylinder, which is right there. The volume is equal to pi r squared h. So here they tell you that the volume is 72 pi cubic yards. So I'm going to plug in the volume is 72 pi. Here in the picture, you are told the height is 8 yards. So I'm going to plug in the h is 8. And the question here says, what is the diameter of the base of the cylinder? Well, the formula doesn't give you diameter, it gives you radius. So here I'm going to solve for the radius. So here I'm going to have 72 pi equals 8 pi r squared. And what I'm going to do is I'm going to divide both sides by 8 pi to give me r squared equals, the pi's cancel, 9. So here when I take the square root of both sides, I get r is equal to 3. So in this circle, they're telling you the radius is 3. They're asking you what is the diameter. Remember, the diameter is twice the radius. So here the answer to the question is the diameter is going to be 6. Problem 30. The figure above shows a regular hexagon. Regular meaning all the sides are the same length. So the regular hexagon with sides of length A and a square with sides of length A. So the square is basically attached to this hexagon. And the question says, if the area of the hexagon is 384 radical 3 square inches, what is the area of the square? Well, the area of a square, area equals side squared. I need to figure out the length of a side of the square. But that side of the square is the same as the side of the hexagon. So what I'm going to do, since it's a regular hexagon, is I'm going to break it up into 6 equal triangles. Here I'm going to break up that hexagon into 6 equal triangles. And these triangles, the central angle, since there's 6 of them, is going to be 360 over 6, or 60 degrees. So each of these triangles is going to have an angle up top that's 60 degrees. And here, since the 2 radii of the hexagon are equal, these 2 base angles are equal, which means this triangle, or these triangles which we constructed, are going to be equilateral triangles, because all 3 angles are 60 degrees. So here's what I have going on. The area of the hexagon is 384 radical 3. Since I broke up the hexagon into 6 triangles, the area of each triangle is going to be 384 radical 3 divided by 6, or if I do the math, 64 radical 3. So the area of each of those equilateral triangles is 64 radical 3. Now, this is not one of the formulas that was given to you in the beginning section, but you were taught in geometry the area of an equilateral triangle is equal to side squared over 4 radical 3. That's the formula for an equilateral triangle, its area. So here, since you know the area of the equilateral triangle is 64 radical 3, I'm going to plug that in for A and figure out what S is going to be. So the area of the triangle is 64 radical 3. That's going to be equal to side squared over 4 radical 3. And now I'm going to solve for S by, first of all, dividing both sides by radical 3 so that the radical 3's cancel. So here I'm going to have 64 equals side squared over 4. And now to solve for the side, I'm going to multiply both sides by 4. So here I get side squared equals 256. And then when I take the square root of both sides, I get the side is equal to 16. So that side is the length of a side of the hexagon, but it's also the length of the side of the square. So here each of the sides of the hexagon is equal to 16, meaning each of the sides of the square is equal to 16. So the area of a square is now side squared, or 16 squared, or that 256. So here the area of the square is 256. Problem 25. A grain silo is built from 2 right circular cones and a right circular cylinder with the internal measurements represented in the figure. And they give you all the different dimensions in the figure. Of the following, which is closest to the volume of the grain silo in cubic feet? Well, basically they're telling you that you have 2 right circular cones. So the formula for volume for a right circular cone is volume equals 1/3 pi r squared h. And they tell you there's a right circular cylinder, so that formula is pi r squared h. So what we're going to do is basically just find the volume of each of the pieces and then add them up. So for the top right circular cone, so this portion right there, the volume is going to be equal to 1/3 pi, and here the radius they're telling you is 5, so it's going to be 5 squared, and the height they're also telling you is 5. So here the volume is going to be equal to 1/3 pi 5 squared times 5, and it looks like they're giving you decimal form, so we're going to use pi is equal to 3.14 because the question says which is closest to the volume. So here it looks like the volume of that top right circular cone is going to be 130.8. And the question says there's 2 of them, and this bottom cone seems to have the same radius of 5 and the same height as 5. So I'm going to multiply that volume by 2 to get the volume of the top and the bottom right circular cones. So in this case here, so far the volume is 261.6. Now what we need to do is we need to get the volume of that middle right circular cylinder, and here the formula is pi r squared h. Well, this particular cylinder has a radius of 5, so it's going to be pi times 5 squared, and here the height of that circular cylinder they tell you is 10. So here we're going to go pi times 5 squared times 10. So here the volume of that right circular cylinder is 785. And then we're going to take that and we're going to add that to the 2 right circular cones. So it looks like here the volume is going to be about 1050, 1046.6. So which is closest to the volume? Here, letter D. Problem 27. A rectangle was altered by increasing its length by 10%. Okay, so we're going to have a rectangle. Its length is L, and we're increasing its length by 10%. So basically what we're going to be doing is we're going to be taking 100% of L and adding 10% of L. So 100% is just 1 if you move the decimal point 2 places to the left. So that's just L. 10%, I'll move the decimal point 2 to the left, is 0.1 L, which means our new length is going to be 1.1 L. So we're going to have a new rectangle whose length is 1.1 L. The width is being decreased by p%. So the width, I'll call it originally W. Now the width is being decreased by p%. So what does that mean? I'm going to take 100% of the W and I'm going to subtract it by p% of W. Now how do I write p%? Well, what I'm going to do is I'm going to start off as p% of W. Well, p%, I moved the decimal point 2 places to the left. That's one way of converting a percentage into a decimal. I could have also written the percentage as a fraction over 100, because that's what percentage is defined as. So 100% is just 100 over 100, which is just 1. So p% is going to be p over 100 of means times W. So here I'm going to have 100% of W, 100% is just 1 W or just W, minus p over 100 times W. And what I'm going to do to kind of clean it up is I'm going to factor out a W. So I'm going to have a W, and W times 1 is just 1 W, and then W times negative p over 100 is going to be negative p over 100 times W. So here is going to be the rectangle, and its new width is going to be this. It's going to be W parentheses 1 minus p over 100. Now, we're going to write an equation that said if these alterations decrease the area of the rectangle by 12%. Well, the area of the rectangle is just length times width, so it would be L times W. This new rectangle, the area is decreased by 12%. So since it's decreased by 12%, the new area is going to be 88%, or 100 minus 12% of what it was. So the area of the new rectangle is going to be 0.88 of what it was. Well, the area before was just length times width, so it's going to be 0.88 times length times width. So here's what we're going to have. The area of this bottom rectangle is 0.88 LW. Well, the area is just the length, which is 1.1 L, times the width, which we said was W, times 1 minus p over 100. So here's what we have going on. We have 0.88 LW equals, now I have 1.1 L times this W times 1 minus p over 100. Now what I could do is I can just rewrite this right-hand side as 1.1 times L times W times 1 minus p over 100. I just simply, since I'm multiplying this times this times this, I just kind of separate it as 1.1 times L times W times 1 minus p over 100. And since now both sides have an L and a W, I can just kind of make them disappear by dividing both sides by LW. So that means on the left-hand side I have 0.88. On the right-hand side I have 1.1 times 1 minus p over 100. And now the question is basically asking me to solve for p. So I'm going to take this equation now and just solve it for letter p. So here I'm going to have 0.88 equals, I'll distribute 1.1 times 1 is just 1.1. And then here I'm going to have 1.1 times p, or 1.1p, over 100. What I can do to make the fraction disappear is just multiply everything by 100. So I'm going to multiply every single term by 100. It's like basically multiplying the entire equation by the lowest common denominator. So here what I'm going to have is, I'm going to have 100 times 0.88, or just 88, 100 times 1.1, which is 110. Here the hundreds cancel, so I just have 1.1p. And here when I subtract 110 on both sides, here I'm going to have negative 22 equals negative 1.1p. And if I divide both sides by negative 1.1, here I'm going to get p is equal to 20. P is equal to 20, or answer choice C. Problem 16. Jim has a triangular shelf system that attaches to his shower head. The total height of the system is 18 inches, and there are 3 parallel shelves as shown above. What is the maximum height of inches that a shampoo bottle can stand upright in the middle shelf? Well, here's what we have going on in this particular problem. You basically have 3 similar triangles. The reason why they're similar is because you have parallel shelves. So I have the green triangle, the smallest one, the blue triangle, the middle one, and then the red triangle, the big one. And all 3 of these triangles are similar. And sometimes it helps to kind of separate the triangles together. So there's my green triangle, and I have the height is 2x. My blue triangle, you have 2x and 3x, so this side is 5x. And then I have the big red triangle, whose, now when I say height, I mean the left-hand side, is 2x and 3x and 1x, which is 6x. Now what I'm going to be able to do is I'm going to be able to set up ratios based on the fact that all 3 of these bottom sides are parallel. Now the question is saying, what is the maximum height of this shampoo bottle if it stands in the middle shelf? Now the shampoo bottle basically goes, I don't want to say halfway up my blue triangle, but the height of the shampoo bottle goes all the way up the blue triangle, and it kind of attaches here. So here's the height of the blue triangle. That's not the height of the shampoo. The shampoo doesn't go all the way up to the top. So the height of the shampoo bottle is basically this height here, or it's going to be the height of the blue triangle, the altitude of the blue triangle, minus the altitude of the green triangle. So you're basically going to have to take this entire blue altitude minus this particular red altitude. So that's going to be the challenge of the question. So they're telling you the height of the whole system is 18 inches. Well, if I wanted to figure out the height of the blue triangle, I know the ratio of the blue to red triangle is 5 to 6, right? Because the ratio of the blue to red left-hand side is 5 to 6, or 5/6. That means, well, the height of the red triangle is going to be in what ratio to the height of the blue triangle? So I'm going to set up the proportion 5 to 6 is the same as the blue height to the red height, or x to 18. So what that tells me is, since 6 times 3 is 18, the height of the blue triangle is going to be 5 times 3, or 15. So the height of the blue triangle is 15. Now what I need to do to get the height of the shampoo bottle is take this blue height minus the green height. So now I'm going to try to figure out what the altitude of the green triangle is. And again, I'm going to set up a proportion. The ratio of the green to red is 2x to 6x, or 2 to 6. If you want to reduce it to 1 over 3, you can. Well, I know the height of the red is 18, so what does that make the height of the green? Well, in this case, 6 times 3 is 18, so 2 times 3, or 6, is the height of the green triangle. So what does that mean? Well, the height of the shampoo bottle is going to be the height of the blue, which is 15, minus the height of the green, which is 6, or it's going to be 9. So there your answer is 9. Problem 3, if a 3-pound pizza is sliced in half. Well, 1 pound is 16 ounces, so 3 pounds is 48 ounces. So if this 3-pound pizza, if this 48-ounce pizza is sliced in half, so if I divide that by 2, then each half has 24 ounces. And then it says each half, so each 24, is sliced into thirds. So each 24 is going to be sliced into thirds, which means you're going to have 3/8. The question is, what is the weight in ounces of each of the slices? And in this case, each slice is 8 ounces. Problem 5, the density of an object is equal to the mass of the object divided by the volume. And the question is saying, what is the volume of an object with a mass of 24 grams? So what is the volume? So that's going to be my x. It says the mass is 24 grams. I'm going to put 24 here. And the density is 3. So I'm going to plug in 3 for D. So this question becomes solving the equation 3 equals 24 over x. I'll put the 3 over 1 and cross multiply. I get 3 times x equals 24, or x is going to be equal to 8, or answer choice B. Problem 18, Jim has identical drinking glasses, each in the shape of a right circular cylinder. So here's my right circular cylinder. And it says the internal diameter is 3 inches. He pours milk from a gallon jug into each glass until it's full. The height of the milk in each glass is about 6 inches. What is the largest number of full milk glasses he can pour from a 1-gallon jug of milk? Well, here I know the volume is going to be equal to pi r squared h. So the question says the internal diameter is going to be equal to 3. So in terms of my circle, or the top, the diameter is going to be 3, but I need the radius. So the radius is going to be half of 3, so r is going to be equal to 1.5. Here the question says the height of the milk is about 6 inches, so I'm going to plug in the h is going to be 6. So that tells me the volume is going to be pi times the radius, which is 1.5 squared, times the height, which is 6. So here the volume is going to be about 42.39. So since the question says how many glasses, how many 4239s can you fill up with 1 gallon of milk, and there's 231 cubic inches in a gallon, I'm going to take the 231 and divide it by the 4239 to get 5.44. And what's the largest number of full glasses? Here the answer has to be letter C, or 5, because if you pour the 6th glass, it won't fill it up. It only fills up about 5.5. So here your answer is letter C. For problem 31, a partially filled pool contains 600 gallons of water. So you're starting off with 600 gallons. and a hose is turned on and water flows into the pool at a rate of 8 gallons per minute. How many gallons of water will be in the pool after 70 minutes? Well, you're starting off with 600 gallons of water already in the pool, and we're going to be adding 8 gallons per minute for 70 minutes. So we're going to be adding 70 times 8, or 560, to the 600, which means here you're going to be left with 1160. So that's what your answer would be for this grid question, 1160. Problem 33, the pes, hopefully I'm saying that correctly, a Roman measure of length is equal to 11.65 inches. So 1 pes is equal to 11.65 inches. The question is asking about feet. So 11.65 inches is the same as 11.65 over 12. Okay, so now they're saying this pes, this 1 pes, is also equal to 16 smaller Roman units called digits. So 1 pes is equal to 16 digits. The question says, based on these relationships, 75 Roman digits is equal to how many feet? So they want to know 75 digits equals how many feet? Well, here's what I'm going to do. Since I know 1 pes equals 11.65 over 12 feet, I'm going to take this out, this 1 pes, and put in 11.65 over 12 feet. So I know that 16 digits equals 11.65 over 12 feet. The question says, how many feet is 75 digits? So now what I'm going to do is just set up a proportion. I'm going to do feet over digits. I know 11.65 over 12 feet is the same as 16 digits. I want to know how many feet is 75 digits. So even though it doesn't really look that pretty, we're setting up the proportion feet over digits. The way you go about solving a proportion is to cross multiply. So you have 16 times x, that equals 75 times 11.65 over 12, which you can just simplify on your calculator. So here I'm going to have 16x equals that 72.8125 number. And here now to solve for x, I'll divide both sides by 16. So here the answer is going to be that 4.550 number. But the question said to the nearest hundredth, so that's 2 decimal places. So here your answer is going to be 4.55.